Hi, I'm Tom. I talk about code. Today, we are going to be smashing another interesting technical challenge on the PlayStation 2. We're going to be tackling indexed textures. My microphone is slipping. Cool. So, the PlayStation 2 supports drawing textures in all kinds of different formats. Up until now, we've been drawing textures. Let's get a nice little color here. We've been drawing textures in true color. Okay, so that means 32 bits or 24 bits per pixel, right? So our pixels will kind of look like this. Let's get a nice little buffer up, right? It's not very even. Now hold on, I want to get the order right here. It's slightly important. And it doesn't say. Cool. So let's say RGBA. So we have a pixel, each one of these components is 8 bits, and maybe we don't have an alpha bit, right? If we're doing 24 bits, we don't have an alpha. But you might ask yourself, if we're taking up this full 32 bits anyway, and we just maybe don't have this set, why would we care? Right? Why not just do 32 bits all the time? This is currently my approach in PlayStation 2 rendering, okay? Everything is 32 bits. Our frame buffer is 32 bits, our textures are 32 bits. The PlayStation 2 does also support another mode for 16-bit color. And this, let's make that actually look like a 6. This mode is really actually quite cool because you have this alpha, this is 1 bit, and then you have B, G, R, these are all 5 bits. My writing is shocking today. 5, 5, 5, right? Here, these are 8. 8, 8, 8. And how the PlayStation 2 handles this alpha bit, if it's not set, then the pixel is fully opaque. If it is set, it goes to a special text A register in the Graphics Synthesizer. It'll go and ask that, and that will give back an 8-bit alpha. Cool. So I've got these two modes, right? And 16-bit, you can imagine, you know, you get twice the pixel density, right? You have less color range. Some colors can't be expressed in 16-bit, in the 16-bit format versus the 32 or 24-bit. I guess you can call this true color. This is limited color, but it gives you a lot of flexibility, and it still gives you, you know, the potential to do interesting, transparent things. So, for example, if I wanted to draw like a smoke effect, where I was drawing a sprite many times, right? If I wanted to draw a sprite just thousands of times at a very low alpha to get a transparency effect, I could get away with this. I could pack my texture that had this smoky effect much more efficiently. And I could have a predetermined alpha that was some, very almost transparent value, and I could just be more efficient with my textures, right? So, that kind of effect drawing, 16-bit sounds like a really great option. Now, there are other options as well. So let's start with 8. Let's start with, the mode is actually called PSM T8, okay? These modes are called PSM CT 24 or 32 or 16. There's also a mode called 16S, and I can never quite remember what the difference is. It has the same texture packing, I believe. But anyway, we'll pretend 16S doesn't exist, because I don't know what it does. PSM T8 is where things get a little bit more interesting. If this is at 32 bits up here, if we have PSM T8, we're going to end up with a pixel packing looking like this. Let's call this I, right? Where each of these things is 8 bits. And now our pixel values no longer actually represent a color, they represent an index. That's why I've called it I. And this is going to get a color, it's going to talk to the CLUT. And this is going to give us back our R, G, B, and A values. Now, you may be thinking, we've just shown 2 different formats for storing RGBA values. Which one will the CLUT use? The color lookup table, by the way, the CLUT. Let me write that as well. That's probably very important to write down. Color lookup. I'm sure someone will ask if I don't write this, and it would be a very valid question. color lookup table. So what format do the pixels in the color lookup table live in? Well, they can be either. So this can either be, let's say either 32 or 16. They always have an alpha value, right? There's no reason to support 24 bits because you're just going to have this top bit that, you know, maybe doesn't matter. I guess let's put a question mark here, right? I don't want it to look like this isn't there for 32-bit. Let's just, I don't know, maybe that's clear enough. Okay, so we can have indexed color with the CLUT. There's also PSMT4. Let's do this, PSMT4. And this, if you can stretch your imagination a little, is going to look very similar. I, 1, 2, 3, 4, 5, 6, I. Okay, where each of these I's is now 4 bits. And again, this is going to go to the CLUT and give us back our RGBA. Right? Indexed color. This isn't a particularly, you know, foreign idea, right? I just want to build this up from the ground because there is a foot gun that I've uncovered with the CLUT stuff that I want to experiment with, but this is going to be important to step through right now because I'm about to blow your mind, okay? Remember PSM CT24, right? We've got this format, okay, we've got these 32 bits, but the top 8 bits are never used. So why would we ever want this? Why wouldn't we just have 32-bit color? Okay, get ready to have your mind blown. Let me introduce you to PSM T8H. Okay, now this mode, it's very similar to PSM T8, right? We have 8-bit indexed color, 4-bit indexed color, by the way. We can only index 16 possible colors, so our palette in CLUT is going to be much smaller. Here we can have 256 colors, but T8H, okay, that's going to look in a 32-bit packed pixel, that's going to look like this. Okay, we're going to have an index, and then we're going to have nothing. So we have an 8-bit index, and then 24 bits of nothing, of garbage. Now you may notice, right, if you're a fan of puzzles, if you're a fan of Tetris, we have two things here that kind of fit together, right? We've got a top 8 bits here that in PSM CT24 isn't used. We've got a bottom 24 bits here that in PSM T8H isn't used. What this allows us to do in VRAM is to overlay, if we have a 24-bit texture that does not have an alpha component, we can overlay an 8-bit index texture in VRAM, right? And so if we point to that address in VRAM, depending on the format of the texture, what we tell the graphics synthesizer the format of the texture is, it will either read the bottom 24 bits as an RGB color, or it'll read the top 8 bits as indexed color. Now, there is also PSM CT4H. This is the same kind of idea where we have an index at the top in 4 bits, and then we have 28 bits of nothing. We also have PSM CT4HH. Okay, now again, this, wait, no, sorry, there is no PSM. Oh, what did I do there? Never mind, that one doesn't exist. Sorry, I got too excited, I got ahead of myself. PSM CT4HH. Now, I promise this is cool enough that it'll make up for me getting it wrong. So, I mean, actually, I'm about to draw exactly the same thing here. So go figure. But I'm going to do it in a more correct way. So let's say it's like this, right? Where we have basically what I drew before, right? Indexed color in the top 4 bits, 4 bits of nothing, and then 24 bits of nothing. And then we have PSM CT4HT, where we have 4 bits of nothing, then 4 bits of index, then 24 bits of nothing. And again, if you use your imagination, these things fit over each other. So we can do this PSM T8H trick, except instead of having one index texture, we can have 2 index textures co-inhabiting the same VRAM addresses. So that's pretty cool, right? This is how we store pixels in a CLUT world. Now there is one more important thing we need to do. We're going to need a new page for this. I don't think I've done a second page yet, so this is going to be exciting in any of my streams. So, how does the CLUT work, right? We know how pixels are stored just in general, and it probably would have been interesting to draw this picture a long time ago, but we're here now, right? It only gets more important from here once we start playing with more exotic modes than PSM, CT, 24, and 32. Okay, so, what does the CLUT look like? How do we use it? Let's start with text 0. Okay, so if we think about the text 0 register, and I will have to just pull it up. Bear with me a moment. I'm going to do my favorite thing, which is to show you the hardware manual. This is what the text 0 register looks like. Hold on, we've got a question in chat. Let me just pull chat up. Sorry, bear with me here. Cool. So this mode is to define which bit mask to use to fetch data from an address. Kind of. It determines a little bit more than that, because it tells it what to actually do with the data as well, right? We can't just fetch the data, right? Because if it's PSM CT24, for example, we fetch RGB data. That's fine. But if it's this index color, there are extra steps, so we can't treat these, we're not just fetching, we're fetching and then transforming into data. And for example, even with PSM CT16, we have to look up what this alpha actually means if there's this bit set. So, kind of, but there's more to it. It's a very good question. It's a very good question. Okay, so the text 0 register, right? This controls texture drawing. And there are, in the top part of this this register, right? We control the graphics synthesizer by setting registers. So far, I've only implemented these bottom fields because these haven't been relevant so far. But we get into CBP, the CLUT base, a buffer base pointer. So this is where our color palette lives in memory, in VRAM. Sorry, in VRAM. Now we have this CPSM. We have to tell, we have to specify what color format our palette is in, and this is going to be problematic, and I'll get to that in a bit. And then there's also the storage mode, which I think we're always going to set to 0. But again, I'll talk about that a little bit more. And then yeah, CSA and COD, what are these? Entry offset, we don't need, and buffer load control. I actually did not come across this in my investigation. So again, I think we might be able to just leave this empty. Cool. So we'll try and set these both to 0 when we do this. But this register's cool. If we go down a few as well, so we have text 1, but then there's also text 2, and you'll notice text 2 we set the PSM texture. So yeah, the format of the texture, we set the CLUT related fields. So the way the hardware manual describes this is it says that text 2 is a subset of the text O register. We can set some things but not others, and so I don't necessarily know why you would do this, basically. I guess if you have to do calculation to work out your texture base stuff, you have to like do a log to get these values to set the register. It's a little bit weird, right? But if you just want to take a shortcut, you can just deal with these. And actually, this does have a gross field, right? Like, bit masking this is a little bit ugly if you're doing things in a weird way like I have been doing from Lua. So, I don't know, maybe we'll use text 2, maybe we'll just go all in and use text O. I don't think it's going to matter much, but it is useful to know that we have this text 2 register, which is just the text O register with a few things not present. Osen23, welcome, by the way. Sorry, I really went into hardware manual land there. So, the fields we care about, right? Well, let's say field 0 that we care about is PSM, is the texture format, right? If this is, let's go, let's make our pen a little smaller. If let's say if star 8 or star 4 right, so you know, if we're setting this to a format that is actually going to use the CLUT, then we're going to have the CBP. This is going to be our oh my, what? You're absolutely killing me here. This is going to be palette so this is the address divided by 64, by the way, which also implicitly means that this address has to be divisible by 64, which is cool, we can deal with that. Then we have to set to CPSM. So format of pixels, let's actually leave a space there, pixels in palette 3, we need to set CSM, and then I think this is it. Except we always set it to 0. And then we're also going to set the other ones to 0. So basically ignore them. So this CSM field's important, right? There are two CLUT storage modes. There's CSM0 and there's CSM1. We're going to use, oh sorry, there's CSM1 and CSM2. They're 1 indexed, even though the integer values are 0 indexed. Now I'm just going to quickly, sneakily, no one's going to notice, me grab my notes for this. Where are we? Okay, so CSM equals 0, we're in CSM mode 1, and that means that our VRAM for our palette is going to be arranged like this, okay? If we have a 256 color palette, it's going to go like this. This is going to take me a little second, okay? You start with pixel 0, okay? Then you have pixel 1, then you have pixel 2, then 3, then I'm going to need a smaller pen. I'm going to need a smaller pen. Let's go. Okay, so 0, 1, 2, 3, 4, 5, 6, 7, 16, 17, these are hexadecimal numbers, 18, 19, 20, 21, 22, 23, 8, 9, 10. You can probably work out what's going on here. So if we have this, like this is in VRAM as a 16 by 16 image, right? And the pixels are laid out like this. So this means that if you have, for example, in our indexed color texture, say this pixel here is 7, right? That means that we're gonna look here in the CLUT, right? If it's 16, we're gonna look here. We're not gonna look here, which would be the obvious place to look, we're gonna look here. Oh, sorry, if it's 15. If it's 16, yeah, we're gonna look here, not the obvious place, which would be here, right? So this kind of doesn't line up with how our brain would logically put the pixels into memory. And if we were to continue this, by the way, you would get 1, 8, 1, 9, 1, A, 1, B, 1, D, 1, E, 1, sorry, that was a terrible E, 1, F, and then you can kind of go dot, 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 right? What do we get? So if you imagine the last row, you'd have E8, E9, E, A, E, B, E, C, E, D, E, 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 F, and then over here you would have F8, F9, F, A, dot, 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 right? So you get this kind of block of 16, and then you get another block of 16. I don't know why it's spread out like this. This is just how the PS2 does it. So when we have our palette in memory, we're going to have to adjust it. That's not what I wanted. We'll have to just make sure we adjust it so that this is okay. Okay. So this is everything we need to know to use the CLUT. How do we do this in code? Well, the first thing we need to do is actually build a buffer that contains our palette and upload that to VRAM. So we could load this from a file. We probably should load this from a file. I started doing some playing around, right? I started building just like an arbitrary buffer. We don't actually need this for a palette. We can just build a PNG and load that into a palette. So let's do that. Let's go Sprite. Let's go 16 by 2. Let's start with a 8 by 2. 8 by 2. Let's start with a 16 color palette, okay? And let's find a nice palette to just copy. Maybe let's go Pico 8. Shouldn't have had a transparent color in here. Cool. Okay, so if we save this as a TGA, we can load this into our engine, we can upload this into VRAM, all using code that already functions, hopefully. Let's see what happens. Let's see what happens. Export. Let's export it as... Where are we going? Cool. Okay. I lost my path there. Tom. Workspace. PlayStation 2. 3D test. Let's go asset. And let's go... I think the TGA exporter works for me here. Not pipeline. Let's call it... Okay, now animation, this is okay. No compress. Beautiful. Let's see if we can load this. Wait, have I done anything bad in the diff? So I need to add an abstraction to just build an empty texture that I can put garbage data into. That should be fine. Yeah, so this should be good, right? If we just run, this will work. Yeah, sweet. Okay, so now if I go into our texture example, I should be able to load this palette instead. And this is a 16 by 2 image. Now I do wonder if these numbers are small enough that it's going to cause problems, but we will find out. This will fail because I don't actually have that there, right? Or do I? Make assets. Okay, so that's doing something. Not quite the right thing, but it's doing something. It looks like we're getting this part of the picture very clearly. 16 by 2. Sprite 2020, let's make it, let's make the aspect ratio right. So let's make it yeah, 64 by 4, by 8 rather. Oops, run. Okay, we're not quite grabbing the pixels from the right spot, it seems. So this thinks it starts here. This could very easily actually be a problem. I really need to know it's loading the right thing, don't I? This is all gonna be pointless if I can't actually load the palette correctly. So, loading. Okay, hold on. Let's just load it in the GIMP. That's gonna be better. That's gonna be better. So where are we? Workspace, PlayStation 2, 3D test, asset, Pico 8 pal. And now if we go export as, export, replace, top left, no runtime encoding. Same thing. Okay, so it's not the encode. Oh wait, hold on. Make assets. I always forget to do this. Okay, so it isn't that. It isn't that. That's good to know at least. Weird. Drawing small textures is weirdly hard because you have these fields, and I can actually show you them because I still got the hardware manual up, right? So the texture width and texture height are set as powers of 2. So this should be fine, right? Like this should be 4 and then 1. I do wonder, width in units of texels divided by 64 though. So, this seems to just mean that we can't draw a texture with less than 64 width. Ayo, shout out for the follow. 16 by 2 is kinda cursed, but valid. Yeah, exactly, right? It looks like we just can't set the right width here. Ayo is someone I know from my Quake days. Ayo, you a big programming nerd too? It's pretty cool. So I assume this is the problem, right? I assume this is why it's weird. It doesn't completely satisfy me, but we'll see. We'll just try and load this in and draw an index texture. So let's just undo our harm here. Ayo, did programming at uni, but too lazy to do anything with it. That's that's not that uncommon apparently. Okay. So whenever actually using this font texture, that's okay. Let's go pal host Pico 8 pal. Is the Pico 8 palette licensed in such a way that I can just do this, by the way? I think it comes bundled with Sprite, but hold on. Pico 8. Is this okay? Am I breaking the law? That's not what I actually don't. I don't think this is gonna answer my question. If any lawyers in chat, let me know. Okay, so load texture 16 by 2. Zymus asks if a palette is even covered by copyright. Who's to say, right? That's a really good question. It's a really weird question. Someone made it, so they could probably claim that it's their intellectual property, right? Okay, so upload textures. We need to upload. Sorry, we called it pal. And then we need to do that other thing, don't we? Yeah, VR. So we allocate space for it in VRAM, right? So now we have a palette in VRAM. If we run this, it shouldn't crash. If I go to, what am I doing? Main. Cool, okay, so we don't crash, which is good. We want to go into, what do we want to go into? So yeah, so we need a way to just build a garbage texture. Now I have done this before, but I want to build a better way to do it. And so if we pull up our diff, right, this is what I was starting here. This function doesn't exist yet, but I'm going to make it exist. So we're just going to really stupidly malloc a buffer, hand it over to Lua, but use our existing buffer API to just fill it with data and then kick it off. And treat it as a texture, right? So in this case, again, I'm going to keep coming back to this, you know, sorry, not sorry. We're going to fill it up with data that looks like this. So we're going to draw like a 64 by 64 texture. That's going to mean, so 8 of these per line, right? And yeah, we're just going to fill it probably with 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, and then just wrap around and see what that looks like when we draw it. So we need to add this function, and we're going to do that in buffer Lua, right? Really awesome file. We've got this common buffer abstraction, and the way I built this is, so we have our draw buffer, and our draw buffer does certain stuff, but we also have a more general buffer abstraction. As long as a buffer has certain things, as long as it has, I think we need a pointer and a head, right? So a pointer to where it starts, and then a head which is the head an offset from the pointer, or is the head the position? Get table to integer. Head's an integer. Yeah, so head is an integer, right? Head, yeah, okay, so it's an offset from the pointer. So that's all we need. That's all we need. So let's do it. Let's just make the dumbest function possible, right? Let's say static draw, not even draw buffer, just buffer alloc. So we grab two integer, let's go, let's call it size. First argument will be the size, and that's it. That's the only argument, right? We just tell it how much data we want. It gives us that many bytes. So let's go. And we could also do this with Lua user data, but I'm going to do it on the C side because our texture management is going to probably have to live on the C side long term anyway, but it's all a bit iffy. Anyway. Now we need to make a table, right? Lua create table. I think this is for two. I can never remember which order these things go in, but I think this one is for two named like table fields. This one's for like array slots, I guess. Lua push. Lua push integer size. Lua set field L -2. So we set the table at position -2, which is going to be the table here. At -2, we'll call the size. We're going to give it a head, which is going to be 0. We start at offset 0, of course, because this is C and not Lua. Everything's 0 indexed. And then Lua push user data, push light user data. Good question. Good question. Hold on. Push, blah, 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 blah. To user data. I think we have to push light user data, right? Push. Yeah, push light user data. Lua distinguishes user data versus light user data. User data, I think, is tracked on the Lua heap, whereas light user data isn't. That is what I believe the distinction to be, but don't quote me on it. Giving... Thank you. High quality comment, AO. I love it. Alright, so push light user data, L. We give it... I should give this a better name. Let's see. I mean, buff isn't much better, but it's okay. Lua set field. Awesome. And then we just return this out, right? This is all we need? Oh no, we need to set the meta table as well. Set meta. And we're just going to copy this. So we share a meta table with the draw buffer that we use because they do the same basic things, right? I was smart enough to split this out into its own little block way back when. So we set meta table -2, and then the thing on top of the stack that's left is going to be this table. We return 1, which tells Lua that there's something on the stack, and that's it. That's all we have to do. Buffer alloc. So new draw buffer. Where's my init? Wait, hold on. Metadata. What's this? Set field index. What have I done here? Set field -2, right? Set field -2 index. Create table. New meta table. Create table. What is... Wait, hold on. So we push a table onto the stack. We push a meta table onto the stack? We create a named meta table. We create a table. We do the thing. We do the thing. We do the thing. So after we do this, what's left on top of the stack? Is it these? I'm very confused. Anyway, let's just add a function to this. Push C function L buffer alloc. That's so odd. Let's just assume this is going to be fine and we don't have to worry about it, and that I was smart in the past, so I don't have to be smart now. CLUT, where are we? Did I not? Where did I... Oh yeah, draw new texture, that's right. So let's go and do something about this. New texture. This is now just RM alloc, and we want a 64 by 64 and 64 by 64, right? So we're using PSM T4, 64 by 64. That's so 1, 2, 3. So that's 8 of these, right? Because 8 times 8 is, wait, how does this work? Okay, so what I'm thinking right now, right? We've got this under control as far as we can create a buffer that represents a 64 by 64 image, right? So so you've got a list of pixels, right? I think we're going to have to go back to the hardware manuals. So 1, 2, 3, 4, 5. I actually need this to be 8 by something at least, right? So let's say we have this. And then in memory, this looks like this. Where each of these has 8 indexes. So what does... See, does this just go in a line and then wrap? Or does this do this weird thing up here, right? Is this like the... What are palettes? So if we're in, say, like a sprite, right? I've got a color palette here. I can come up to this color. If I unlock my palette, I can modify it. And the color in the actual image is going to change. Because this color isn't a color on its own. It's just an index into a palette, right? So, you know, we can change this to whatever we want. And this means that when we actually store this image, we don't have to actually store, like if we store this palette somewhere, we can just say that this is number 1, 2, 3, 4, 5, 6 in the palette. We don't have to say what RGB value it is. We can just give it a number, right? And so in PS2 world, you know, I've kind of done a bit of a complex picture, but we can use indexes to look up values that actually contain colors in this color lookup table, the CLUT. And so we're like halfway there, right? Compressing things by getting rid of some colors, exactly. We have less total colors. We can't just pick any combination of RGB pictures. We now are saying upfront, these are the colors we're going to use for this texture. You know, here's what we can do. And this means that we can have some very, very compressed textures. Also, watching PS2 dev on a PS4, that is freaking awesome. I love it. I love it. It's really cool how consoles have become more multimedia machines, and it would be awesome to see some more multimedia possibilities coming out of the PS2. Okay, so each pixel in our PSM T4 image has 8 pixels worth of data. Each byte has 8 pixels worth of data. So it stands to reason that we only need... Well, 8 times 8 is 64, right? So we only need 8 bytes to represent a 64 by 64 texture. How does this help with efficiency? So efficiency in terms of like VRAM storage. So if we want to store a texture in VRAM, right, a 64 by 64 pixel texture, or I guess texel texture, if you want to be more precise. If we're using 32-bit color, then we're going to need a byte per pixel, right? So in other words, we need... Oh wait, hold on, this is just 64. Don't mind me. But, so each pixel corresponds to 1 byte. In this case, each pixel corresponds... Or each byte corresponds to 8 pixels, right? So we have a much smaller VRAM footprint. And as textures get bigger, this you know, becomes, I guess, more significant. And because the PS2 only has 2 megs of VRAM, right? It's a fairly limited system for VRAM. So any little hack you can do to mush textures together, to, you know, to reuse textures, right? Because the other cool thing about palettes is you can have textures in VRAM, you can change the palette and then redraw the texture. So there are lots of cool tricks. There are lots of cool things you can do. Okay, so one row. So I'm going to do the naive thing here, right? I'm going to assume this. I'm going to assume this. Let's go back to CLUT. Let's go into, actually, PS2 init. Let's not go into PS2 init. Let's go into PS2 prog.slow2d. So we're going to tell it to use our Lua renderer. Now if I run this, it doesn't crash again, which is good. So I come into the start here, let's create a texture. New texture. Not love, sorry. Okay, now something's gone wrong here. Cannot upload texture that has not been allocated. Draw 2D. 242. Upload texture. Cannot upload texture that's not been allocated. Let me actually define these as locals as well, just to be a bit cleaner. The hardware has support. Yeah, the hardware is built to support this. So the CLUT that I'm talking about, this is a hardware component of the PlayStation 2. This is all like graphics synthesizer registers. This is hardware. Okay, I've done something weird. If I come in here, surely this isn't gonna... I keep trying to test stuff in love. Okay, so we've broken something by doing this. We've really broken something that's doing this. By doing this. Can I get a stack trace? I don't know. Why does new texture tell me about uploading? Or why does it break something in the other textures? Oh wait, hold on. I worked it out. There we go. I need to build. I added this new function, but I didn't actually build. That'll do it. And so then it crashed out in this function, so then when it called upload textures later, this hadn't run. So yeah, there we go. That was just me being silly. So let's go. Manually start Docker. I do this every time because I like a nice fast startup. I like to start as little stuff as I actually need when I boot my computer. And now we should be able to build a few warnings, each undeclared identifier. Okay, that's not good. Let's go to buffer lure. Let's just put this in the head. Let's not put this in a header for now because we don't actually need it anywhere. Draw buffer free is defined but not used. That's okay as well. I don't love it, but we'll survive because we never actually call free, and now this works again. Awesome. So now what I really haven't thought about as well is how I'm actually going to write these, 4-bit indexes. Because the only abstraction I have for building a texture, and let's actually make a function for this, just so that it gets split out from here, because otherwise it'll get a bit ugly. Let's go function build for text. So for I equals 0, let's go I 0 to 64, 1, increments of 1. So we'll have all the numbers 0 to 63, except we want to do this 64 times. So j equals 0, 64, 1, do. Right, 64 by 64. 64. I keep thinking just 64 by 1 for some reason. We're going 64 by 64. So a new texture 64 by 64. Wait, hold on. I've done something else silly here. Because I've hard-coded this format to PSM 32. Let's go. Let's pass in a format as well. Let's see what we get here. And then we'll go width times height. Oh, let's go. I think I actually support this, right? Texture. I think in VRAM, I might have a. Yeah, I have a size. Okay. I support this. So if I go back to new texture, PSM align. Let's just say the alignment's 0. That's cool. Okay. Yeah, awesome. So this should take 1/8 of the space. I think we actually support... I don't actually know if we ever read this field where it matters. Do we ever read this field format? I don't think we read it. I think we always just hard code it to... Oh no, PSM? Where does PSM come from? Oh no, yeah, no, we read it, sorry. I'm not giving myself enough credit here. So let's go back to CLUT and let's remember to tell it what format of texture we want, which is gs.psm t4. I think I have this, gs lua psm. Okay, I just called it psm4. Slightly nicer name. Cannot upload textures. Yep, that's fine. Okay, attempted to perform n mod 0. Salty Doubts, welcome to the chat. How's it going, man? Are you back at work yet, or are you still chilling? Oh, nice, you're working. About to grab lunch. I'm off for another week. It's really exciting. I'm gonna be living it up and doing a bunch of PS2 streaming. So, you know, just put me on in the office, man. Just get me on a big screen. It's the dream. It's the dream. Yeah, so this is controversial, right? I need to add an at everyone. So I'm not sure if I want to do this, right? How would people feel if I pinged everyone when I go live? Or maybe I should make a role in my Discord that people can add so that when I go live, like there's a followers or something. Yeah, just those people get a ping. Holy crap. 155 hertz, 1440p, 34 inch. It's a pity that I'm streaming at a quality YouTube does not actually consider HD. That's a waste of your monitor, my friend. But I love it. But yeah, no, so PSP, 2 megs of VRAM, 16 color palette, 8 times less memory for textures. Exactly. You save a lot of space. As PSP, it was more important. Very similar for the PS2. I think the PSP has the same CLUT architecture. It has the same GS stuff in a really similar configuration, right? PS2 has 4 megs of total VRAM, but I don't know once you've factored in frame buffers how much of that's actually usable, the 2 meg for the PSP, but yeah. You don't have a lot of VRAM to work with. That is the gist. Okay, so now if I run U, it's fine. This is all good. Are these techniques still in use for modern GPUs? Modern GPUs with gigabytes of VRAM, it's less important to have textures that are paletted and, you know, packed together. I'm sure people still find ways of doing compressed color spaces, but I don't think it's anywhere near as common as it was in the PS2 era, right? When you think about 4 megs of VRAM versus, you know, 8, 16 gigs, they're just like completely different ballparks. Okay, so we actually probably don't want this to be 64, right? We probably want to do, because each 32-bit word here is going to be 8 pixels, right? And we can only write to these buffers. I only have an abstraction to write in terms of 32-bit words, 32-bit integers. So let's go 8 times. Let's go back to texture.lua and just see, what have I done? Not texture.lua, sorry. New texture, data. And then let's go into buffer Lua and just double check my APIs here. Push in. So yeah, push in. Push in. Okay, this is less easy than I thought. We want. What does this look like, right? We're writing a value. We're writing. 0. So we're in 4-bit increments, right? 0, 1. How do I think about this? So I guess let's think about it in 8-bit chunks, right? So in bytes. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, A, B, right? It just goes like this. And then alternating words, yeah. So this is the first and this is the second. So if I mod 2 is 0, then we write 0x 01, 2, 3, 4, 5, 6, 7, else t data push int 8, 9, A, B, C, D, E, F. Thank you, Soti Doubts. Yeah, I'm gonna enjoy the week off. I've been out a few times, but yeah, it feels pretty sus going out right now. I went to Melbourne Central last Monday, and I felt like a bit of a madman, but I kind of like snuck in the back streets. There weren't actually that many people there. Apparently shops are kind of quiet. Cool. Okay, so we've built a texture. Let's upload the texture and try drawing it. Now I need to allocate the texture as well. And then let's see what happens if we draw it. Let's draw it at like 100, 100. Let's go 64, 64, 0, 0, 1, 1. These are our UVs or STs, depending on your terminology. What happens? Something goes wrong. Index a nil value, local T. Okay. T is a nil value. Build for text. It looks like we're returning 0 from this. We are, because we're not actually returning, or returning nil rather. Let's return something. And now we get TLB messes. So now we're back here. We were here last stream. Okay, attempted to index a nil value, local text, 38. Wait, where was that? Where did this error come from? VRAM, local text, VRAM 38. So if I go to VRAM 38, that's not good. That is not good. So let's go back to CLUT. So when we're calling VR texture, image is nil. But it shouldn't be nil because this doesn't complain. VR texture image. It really just says that text is nil, doesn't it? Yeah, width, height. We've got all the right stuff. Looks like we've got all the right stuff. We've got a follow from Promecha Fox. Thank you very much for the follow. Welcome to welcome to the mad world of PS2 dev, where we look at fun errors like this. This looks like another memory corruption issue, actually. Okay, but we've got to work this out. Attempted index a nil value, local text. See, this is one of these things that doesn't make sense to me, right? Am I overrunning my buffer? Okay. Okay. Let's go back to buffer lure. Let's go to buffer alloc. And let's do a trace log here, and let's say allocating lure. Except I need to do it after there. Size equals. Cool. And then let's also go to push int. Buffer push int. Oh no, hold on. That wasn't right. Buffer push in. This one. Oh look, I've got a to-do about checking the size here to make sure we don't overrun. Let's do the lazy thing again. Oh, hold on. Now this is gonna just like absolutely blow up. Okay, let's check this. Let's check the size. Let's be lame. Size equals lua to integer lua push string L size lua get table L1 lua to integer. Cool. So let's grab the size and let's say if head greater than or equal to size log and we just do nothing, right? We just leave this in a weird, bad state, but we'll at least have a log message that tells us what's going on. I think that was fine. I think those errors were fine. I didn't really read them. Okay, there we go. We hit, yeah. So we're trying to do bad stuff. We're trying to do very bad stuff. Wait, hold on. Let me also change my log level here. I'm using magic numbers for my log level at the minute. It's not the best way to do it, but it gets the job done. When we create size equals 512. Interesting. Interesting that it's this buffer that is having issues. Okay, so if I go... So it's a 64 by 64, right? So the size... Let's do some math. Let's do some math. Okay, so 64 by 64 is big. But we have 8 pixels per word, so we expect this to be 4096 divided by 8, which should be 512. Perfect. So 512. So then we're doing this 64 times 8 times, and 64 times 8 is 512. Does Lua... Do I have to go to 7? Is this just a weird Lua thing? No, it still overflows. Okay, well let's go simple, right? Let's just go smaller. And now we get to our next problem. So image adder never gets set here. Draw 2D 276. So if I go to draw 2D 276, cool. Data add, yes. Yes. So this isn't a table. This is actually a buffer. So if I go to load texture, so I don't actually, okay, I'm slightly out of step with this. Why isn't, yeah, okay, so there's an extra layer of indirection, right? Hold on, bear with me a minute. I'm just gonna have a quick BRB. I'll be back shortly. Alright, sorry about that. Just, I felt my brain just kind of stop. I needed a minute there. So we have this adder field in at textures, but this isn't really part of the normal buffer spec. Only textures need this, but just because of how Lua is, it was easier to not only have this pointer available, but to also push its address just as an integer so that I could use it later. So let's mirror this when we create our buffer. Okay, it's the simplest way to do it. We'll just say buffer alloc. We'll just say Lua push integer. What did I call it? Buff. And this will now just work. This draw buffer free thing I need to deal with, but it's okay. It's okay. Cool. So this works. This works. This works in that it doesn't die. It doesn't work as far as actually drawing anything goes, unfortunately. Let's lower our log level again so that we bloody love 2D. Okay, so it works, but nothing gets drawn. It works, but nothing gets drawn. Because we're not setting those CLUT registers. Of course, of course. So I've thought about this long and hard over the last few minutes, okay? And I think it's gonna be easier to just set the CLUT separately from the rest of the texture information. So in other words, to just set it through this text to register. This way we can just freely update the CLUT without worrying about anything else to do with textures, right? So we don't even really need to set PSM here. We can just always default this to 0. We can ignore this field. Again, like, you know, in the long run, so for example, if we're drawing textures where they're overlaid on top of each other, so if we draw a 32-bit texture, then want to change to a 4-bit indexed or an 8-bit indexed overlay texture, one of these formats, that's probably where you would set PSM here. But for our use case right now, we're going to ignore this. I don't think we're going to do overlay textures as cool as they are, unless we really, really need to. But that's a level of like planning and custom tooling and stuff. That's a whole extra thing to bite off. But this is a lot easier, right? And I hate doing this in Lua, but we'll do it. We'll make it work. We only need to set 3 fields here, I'm pretty sure. And even CSM we're saying to do. So we need to set CBP and CPSM. And CPSM is always going to be 0. We need to set CBP. It just gets easier the more I talk about it, the more I think about it. Okay, so. We're building a simple texture. We need to set CBP. Draw 2D. So we need to add a new function to this, right? We need to say draw. So when we set the CLUT, we need CBP. Let's give it a texture, I guess, which the CBP comes from, and then everything else flows from there. Because we're going to assume CSM's always 0. Yep. Okay, perfect. So let's go self.buff. How have I done this in the past? How have I done this? DMA tag raw. Yeah, gif dot blah 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 blah. Okay. This is in our GIF abstraction. So GIF dot text2, and it's gonna have text dot data dot adder divided by 64. I think. No, that's not. Hold on. VRAM texture base pointer. That's it. Text dot base pointer divided by 64. PSM will be. CPSM will be 0. CSM will also be 0. Cool. And that's all we have to do. That's all we have to do. So we go into GIF, we actually implement this, and this is where we do all the gross stuff. Let's find where we do text 1 and text 8. Oh, interestingly, already thought about text 2, but we didn't break it down into anything. We're just like treating it as a big chunk, which isn't great. The first word we don't care about, right? The first word we actually don't care about. I don't think we've used this anywhere too. I probably need to just quickly check that. Yeah, perfect. Okay, that's the one we just added. So we haven't used this yet, so we can change this API, CVP, CPSM, CSM, sure, let's do it. Then we go local v equals CBP times, okay. So this is at bit 37, but we're starting at 32. We do this in two 32-bit words. So this is at bit 5, so we multiply it by 2 to the 5. The grossest bit masking manipulation you have ever seen. I hate it, but it's okay. And then we're going to ignore the other fields for now. And this goes in the upper word. So, and that's it. That's all we do. That's all we have to do. That's seriously all we have to do. I love it. I freaking love it. Okay. So if we come into CLUT, we go D2D set CLUT. We set it to PAL. I wrote CPB instead of CBP. Thank you very much. CBP. I did. I am the worst. I cannot. I really struggle with these things. I really struggle. In B. Yeah, that's actually a lifesaver. Bloody legend. Okay, 52. 52? Did that say 52? Oh, thought I needed to sneeze. Never mind. 52. B. Give set ID B. B not defined. That is because I've done something wrong. Done something wrong here. B. Oh, I didn't pass a buffer in. And now, again, we're running, but we're not drawing. Okay, so, I mean, look, this is looking good, right? This is looking promising. We're going to have to go in and start looking at the actual draw commands now, because I don't know what else to do. So, I think we've set everything up properly. This all looks good to me. So we have our uploads and stuff in this first frame, which, who even knows? Clear the screen. This is, what is this? You're a sprite. You're a single sprite. Oh, I guess the other thing I need to check is what register is text to? 16. So we're looking for 16 being set. 16. It looks like maybe isn't set. Set CLUT. Ooh, that's not good. That's really not good. Why did... Weirdly, segfaults if Lua has a syntax error. We really need to fix that in PS2 Lua. It's a bit of an oversight, but so be it. Setting CLUT to this. Setting CLUT to this because this has to be math.flawed. But that's still not quite right. Okay, let's scroll up. So we can see it's being set. Where are you being set? We want to see a register. We want to see register 16 being set. And I don't see it. I don't see it. Set ID, set ID, set ID. This looks like how we do it, right? Like, I don't know what has necessarily changed here. Maybe are we not in... Do I need to be part of a GIF tag? I guess I'll start a new GIF tag and just wrap it in here. gift dot. That's probably it, right? That's probably what was missing. Gift tag, setting the prim register, setting, this is a bit of texture stuff, right? And setting prim again. Oh, this is my favorite question. This is my favorite question. Hold on. Where did, I've lost chat again. I keep putting chat somewhere and just forgetting where it is. It's not here. Where have I put chat? Where'd it go? It's surely not there. bloody tiling window managers. This is the only thing that happens, right? I keep losing chat. Oh, cool. Now I actually lost the question. Okay. Never mind. It's gone. But Blemgang asks, how am I using Lua here? The answer is pretty poorly. Did I? Okay. Cool. Whatever. So Lua. Building draw buffers on the PlayStation 2 is kind of complicated, and I want to be able to experiment with it fairly freely. So I've built the world's grossest Lua abstraction to do just that. So I do all my bit manipulation in Lua for now. There is also a C re-implementation of this. There's also a C implementation of all this logic, which is a lot faster, but when I'm experimenting with a new feature like this, it tends to be a lot quicker to just throw some Lua at the wall. So for example, we need to build gift tags, which contain commands that set registers in the Graphics Synthesizer. One of the cool things I can do here is just specify the format I'm gonna send these commands in a list, and it will work out the length of the list and do a bit of automatic stuff that I can't do quite as automatically in C, because I can't just make an arbitrary list without doing a malloc, right? There are a few nice things like that. So yeah, the Lua version of building these buffers has a few nice edges, but it's still very, very frustrating to work with. And especially when I'm setting something, I can see I'm setting it, but it is not here. It is not here. So this is a sprite being drawn, and this is a sprite being drawn. Yeah, nice. Yeah, I mean, it's a bit crazy, right? No one's ever done it quite like this before. There is another project using Lua, but that's wrapping high-level draw calls in Lua, and then everything is just like low-level C. This is literally building every draw buffer. Every word in here pretty much is placed here from Lua. So where in my draw do I actually do this, right? So set color. Okay. So let's go to draw 2D. Let's go to set color. Okay, the other question in chat is how does, oh no, I found chat. Hold on, here it is. How does that get put into the actual C game? So I'm gonna do game logic in Lua. Even with the C backend for the renderer, I'm doing the game logic in Lua. Binding Lua into C is really easy. It's easy to call Lua from C, it's easy to call C from Lua. Really, really nice language. If you've never done it before, it's worth playing with. But the goal is that everything is in service of the highest layer and the actual logic being Lua. Oh yeah, so I guess I'm mixing a bit here, state with actual like gift tag stuff. So let's, instead of doing this, let's modify this in state. Let's say and CSM equals 0. Cool. You heard Lua can be embedded easily. You didn't realize it was this easy. Yeah, so I built a new Lua API in the first 10 to 15 minutes of this stream, I think. It's really easy. You're just kind of like, hey, you know, put some stuff in a table, right? It's like 2-3 lines. You know, expose a function to Lua. You push the function, you give it a name in a table that you create up here. It all works in a stack. It's all super easy. I highly recommend it. Highly recommend it. So now instead of actually doing this here, let's go self.clut.base. What did I call this? I hate it. I name something, then I forget immediately what I named it. Text pointer. Let's go. Self.clut. CSM equals 0. Perfect. So now when we come up and draw a sprite, okay? Because we only care about this when we draw a sprite. Upload texture, sprite. Now it's part of our sprite setup. Well, first things first, actually. Buffer Lua, set text. Yeah, I don't actually have an argument for this, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, maybe I'm thinking I'm passing that information, but it doesn't matter. Let's go. We have to set it after this. Gif.text2, self.buff. And then we just pass in self.clut.text. This is a terrible name. I've already forgotten it. Text pointer. Terrible name. Terrible name. Where are we? And that is definitely what I... CVP... yeah, we're ignoring the other things. Okay. Now if I run this, it's going to crash. That's good. That's progress. That means we're actually doing something. And I want to see... somewhere around here. No, this is... oh no, so the upload. We crash after the upload. Setting CLUT 2. That's okay. Why do we crash here? Why do we crash? This draw buffer has something bad in it that it should not have. So this is our upload of our textures. What have I changed that would hurt that? It can't just be this, right? Okay, it is just this. That's weird though, because this shouldn't even, like, I don't even see this coming into effect here. We don't draw a... No, we do draw a sprite in our first frame. But then why... Okay, okay. Something's gone bad here. It could be that I have not told it the right number of things. There we go. That explains it. That explains it. So where do we have a gift tag with 5 things, right? This, this, this. I see what's happened here. Okay. I see what's happened here, I think. So this is a gift tag where we draw a sprite. No, but this is a gift... No. This is a gift tag where we draw a sprite where we don't care about the value. No, this is the gift tag where we... The first sprite we draw, it's irrelevant. The second one we draw, we expect something... We're not building this right. Okay, so the register number should be in this byte, and instead it's over here. But we use this machinery for everything. How is this going so wrong? How is this going so wrong? Set AD. Like, this is how we're setting all of our other registers. Set AD. Push this, push reg, push 0. Okay, so I guess just to try this out, let's put a really obvious value in here and just see what that looks like in our draw buffer, right? 1, 2, 3, 4, 5. Okay, so is it... Have we fluked and hit on some magical situation where there's a 16 here? That's possible. Oh, you know what has happened. Okay, so if you think about this, right? If you think about assembling this buffer, we're combining 3 words here into a quad word, right? Lua defaults things. Lua has weird rules about defaults. So if I go into ps2 const and I look at the registers we've defined, you'll notice there is no text2. So Lua happily defaults this to 0. So now if I add this in and run, we actually get something on the screen. So let's look at the draw buffer first before we get too excited, right? So 16, we set this to something. That's great. That is bloody excellent. We need to get rid of this garbage now. And I think it's actually just fluke that the value we're setting the prim register to happens to be 16. That was confusing me. That was drawing my eye. Okay, so this is now 0. Now if we run, this doesn't look right, but it's something. It's something. Okay. Let's go simpler. Let's go simpler. Let's do this in... Let's divide our image into 4, okay? So, well, I guess we can't do that, though. We can't do that until we can actually fill the whole image up. Okay, well, that works now. That's good. 64? Is this dangerous? Okay, we can now populate the entire image. That's good. So let's go. If I greater than 4, then what? I'm imagining we've got our image, right? We're gonna cut it into 4 parts. So we're gonna say 0, 1, 2, 3. This is gonna be, well, you know, up until the midpoint, right? So 32, 32. Except this is 32 divided by 8, which is 2 to the 5, 2 to the 3, 2 to the, which is 4. I should know that off the top of my head. So 4. So if we're bigger than 4 pixels across, if we're bigger than 32 pixels down. So if I is bigger than 4, then, well, we need to store some color, right? So let's say local v equals 0, v equals v plus 1, and if j is greater than 32, no, that doesn't, that's bigger than 4, screw it, this will do. Then, I was thinking bigger than equals because we're 0 indexed. Then v equals v plus 1. So this isn't quite what I drew, but it'll be okay. Data.push int. Now we need to multiply or like duplicate this throughout. So what I'm actually going to end up with here is 1, 1, 2, right? But I need to generate not just the value 1, I need to generate 1, 1, 1, 1, 1, 1, 1 in a language that doesn't have bit shifts. So it's, local vv equals v plus v times 2 to the 4 plus v times 2 to the 8 plus v times 2 to the 12 plus v times 2 to the 16. Do I just do this? I guess this works. 2 to the 20 plus v times 2 to the 24 plus v times 2 to the 28. Right? What happens if I do this? What number do I get? Oh, hold on. This all happens in like the first. Also, this still overflows weirdly. This turns into a scientific number, which isn't good. We need to math floor some of these. Oh, what a disaster. What a disaster. There's got to be a better way to do this, right? There's got to be a better way to do this. If we have the number, right? If you think about 0x, let's say 3, 3, 3, 3, 3, 3, 3, 3, right? Divided by 3. Do you just get? Is that right? Does that work? Can I do this? Can I do this as stupidly as I think? 4, 3, 6, 9. Yeah, it's 1, 1, 1, 1. So why don't I just multiply instead of this by... That should work, right? We still don't get the right answer, but that's something. That looks like something. Let's go image. Let's blow it up a little. Let's blow it up to 120. Let's blow it up to 256 by 256. And I mean, these colors look like they might all come from this palette. Does anything look like it maybe doesn't? That yellow looks right. The reds, the pinks. Maybe these purpley colors, right? That doesn't quite look like it comes from here. Okay. There's a few things going wrong here. There's a few things. Oh wait, hold on. No, I messed with the palette, didn't I? There we go. So yeah, definitely no purple like that on this palette. And there's like 3 colors quite close together. Okay. So the question is, right? So I mean, first things first. What are we actually drawing? Because like these should all be the same values, but something's going wrong with the buffer construction as well. Because this shouldn't be happening. Buffer push in overflow. Why are we still trying to allocate so many times after the end of this buffer? Do I just have to say 63 and 7? That's probably a Lua syntax error. Or not. What's going wrong there? Ah, yeah, cool. Oh. Accidentally pasted some garbage in. Okay, so does this still overflow? Yes. Why are you overflowing so much? How many overflows is this? This is like hundreds. Allocating buffer for Lua, size 512. That's what we expect. 64 times 8. That's what we expect. Pixels. Because it's 64 by 60. Yeah. So each row in the image has 8 bytes. We're going 64 times 8 bytes. Okay, we're gonna go crazy here. Push int buffer push int. We're gonna go crazy. We're gonna go trace push value okay, so push value into buffer pointer at head. Okay. We need to build. And this is going to yell at me quite a lot. This is going to just like blow up my logging. Because all of our draw buffer construction is done using the same abstraction. Okay. Pushing into this buffer. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. Blah, 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 blah. 4, 8, 12, 16. And then it just keeps going. Oh. Let's just add more debug printing, I guess. Put in text 4 at okay, what does it think it's doing here, right? 1, 2, 3, 4, blah, 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 blah. After 60 pushes, right? Am I doubling up somehow? 0? let's not multiply. That was a mistake. Okay, so 0, 0, blah, 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 blah. This is... for first 8. I must be doing something really silly here, right? We're writing 4... Oh wait, each oh, hold on. I'm short a division here, right? Because I'm thinking in bytes, but this is... No? Yeah, I've got this many. I've got 64 times... I'm writing 4 bytes at a time. This should be right, shouldn't it? No, because I'm allocating 64 times 8 bytes, but I need to divide this by another thing, right? Does that make sense? No more overflow? No more overflow? Still overflows. Still overflows, 32, blah, blah, blah. Still overflows a little. What am I missing here? 64. ...64 integers. Each of those is 4 bytes. We have 64 by 8 bytes. I gotta draw a picture. This was good. Drawing a picture helped here. So, page 3. So many pages. We have a 64 by 64 texture. Sorry, I just need to quickly check my phone there while I, again, formulate this a little bit more in my head. Cool. Okay, so 64 by 64 texture, right? Pixels, or texels. If this was PSM 32, this would be this would be 4 bytes per pixel, right? To a total of 64 times 64 times 4 equals whatever this is. 64 times 64 times 4, 16,384. Which is also equal to 64 cools to push in. Okay, so now we can use the same logic. PSM4, where we have per byte 2, 3, 2 of these per byte, right? 1 B. So 2 pixels per byte. Two texels per byte. Okay, here we go. Thank you to everyone that's toughing this out with me. And GGMon, thank you very much for the follow. Welcome to the PS2 Madhouse. Okay, 2 texels per byte, or 2 pixels per byte. I'm a little bit unsure about texel versus pixel terminology. So 64 by 64, right? So this comes out to 64 times 64 times 1 on 2, right? This is... So if it was 1 byte per pixel, it would be 64 by 64 bytes. This is 64 by 64 times a half. 2 pixels per byte equals... sorry, I think I'm getting a phone call. I am. Do excuse me for just a second. Sorry about that, just a bit of housekeeping. Okay, so 2048. Which makes sense, because yeah, 64, 64, 4096. I know that in my head somewhere. So that's 2048 bytes, right? Which is also going to be equal to... Wait, so this many bytes, so equal to... Which is... Wait, hold on. Yeah, that divide... That... Yeah, I'm right. That divided by 4, which is 2048 divided by 4, 512, right? Subtract 4 powers of 2. That's all fine. That's all fine. That's all very fine. Where did chat go? Cool. Similar issues when writing a BMP parser in OpenGL. Is it possible my text buffer is set to RGB, but I'm writing 4 bytes of data instead of 3? No. No. The CLUT doesn't support 24-bit color. It only supports 32-bit or 16-bit. How's it going? What do we have so far? Do we have textured tries? Yes, I had... no. Well, kind of. Yes, but only in 2D. I've got textured sprites. Which is good. And now I'm doing color palette rendering, because it's actually going to be really important to maximize GPU space. Okay, so... But now what I'm really struggling with right now is some maths, right? Just some good old-fashioned maths. Every time we call push-int, it advances by 4, right? So 64 times 4 is 512, yeah? No, 64 times 8 is 512. So why can I not call this 64 times 8 times? Why does this overflow? What logic error has taken this to some bizarre place, right? What is going on? 0, 1, 2, 7, 8. Okay, well this is bad because it actually hits 8 and it should only hit 7. That's too many things. And this needs to be 63 as well. Okay, so this is fine. This is fine, right? This is actually fine. Why does the head advance? How much does the head advance per thing? 4, 8, 12, 16, blah, 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 blah. It advances by 4 each time. Oh, it advances by 4 each time. Hold on. So so if I do this, so if I do it 2. Oh, and I was going to 3 instead of 2. So this won't overflow now, in conclusion. My maths problem was having a 2 here instead of a 1. This checks out. This checks out. Okay, so hold on. Let me clean some of this up, because this is very, very noisy with logging at the moment. This is still wrong, but this is more correct. Now the problem is... Actually, let me get that back, because we're drawing... Is there a way to Lua hex format a string? String format. Ah, there we go. From hex 2 hex. String.byte. What's string.byte? Okay, whatever. Okay, so let's actually dump out the value we're writing in hex and see if it's what we expect, because we expect this to either be all zeros, all ones, or all twos. All zeros, all ones, or all twos. And then I want to get rid of this. Hold on, buffer lure. This is just so noisy. Absolutely hate it. Okay, this is better, this is better. So when we generate this, we get 30, 32. 30. How do you get 30 from this, right? Well, I mean, first things first. If I is greater than 0, greater than or equal to 1, I guess, because of how we've written this out. But still, 303. Oh, because I'm converting it to a byte. I want it to be 8. Doesn't that check out? Don't you love it when these things make sense? Yes, all zeros, all ones, all zeros, all ones, all zeros, all ones. 1, 0. And then it's just a question of which order these go in, right? I want these to be in big blocks though, so we get 1s down here, 0 here, 1s. Why not just set it to all ones? All ones all the time. Because then this makes even less sense, right? So we're pulling from a color palette here, this color palette. We've set every pixel in the texture to the same thing, and we're getting this. So there are a lot of ways this could be going wrong, right? But the fact that we've got different things every time tells me that maybe we're not setting the mode correctly. Maybe we're not setting the mode correctly. Maybe that's one to check. So let's go to GSLure, where we actually set this stuff up. GSPSM 4. GSPSM 4. Okay. Now, when we actually draw the texture, we have to set up the text 0 register, which we do in draw 2D text set text. We have to use a special function for this because it's complicated. Because it's very complicated. Now, here's a fun thing to double check. Do I actually set this? Yes. When I make the new texture, I say PSM4 texture format. So when we draw a texture, okay. You tried to run my elf on ulaunch elf and it showed a black screen. Maybe. You might have to leave it a little while to load. If you don't have the assets and stuff in the right path, then yeah, it probably will black screen. It should do something. It should at least print something. So that could just be, that could be a lot of things. That could be a lot of things. I got it running, like my latest build that I'd been playing with. I had it running over PS2 Link yesterday, which was cool. But yeah, I will work on getting things actually running on PS2 probably in the next few days because I'm going to have time to do it. I'll improve that experience a little bit. But at the moment, everything is just kind of, you know, an unofficial, I'm just throwing shit at the wall release. Oh, I realized what happened. When we set text 2, we override PSM. This is really obvious. This is really, really obvious. Okay, text 2 overrides this PSM field. So here we set text 0. We say, here's all the information about the texture we're drawing. We'll tell you about the CLUT later because it's easier, because this is a really hard register to fill up, right? Especially because of this, because it runs over a 32-bit boundary. The bit manipulation is just awkward, especially in Lua. So we'll tell you about CLUT later. But when we tell it about the CLUT, this field down here, this PSM field is going to override it. So we're telling it that we're giving it 32-bit color. This makes sense. This makes a lot of sense. This makes a lot of sense. So what we need to do down here is say text.format. And now we need to go into gif.lua. We need to say cpp. We need to set this PSM. This PSM lives at bit 20. So this is going to be PSM times math.floor PSM times 2 to the 20, I guess. Now if we run, we crash. That's okay. Cannot upload texture that has not been allocated. Bad argument number 2 to format. Number expected got nil. CLUT 19. Number expected got nil. Number expected got nil. Okay, well that's fine. Okay, now we're back to nothing drawing, but this is better. This is better. Now, where are we? 16. Okay, let's think about this number here. Let's think about this number here. So let's go text, let's get a nice monospaced font. And let's pull the size down a little. Okay. Cool, so what does this look like? What does this look like? 1, 2, 3, 4, 5, 6, 7, 8. So here is our first word. And here is our second word. Oop, let's draw an actual W there. Okay, so we've got our 4 bytes, right? This comes out to, let's write it out in full. 0, 0, 0, 0, 0, 0, 0, 1, 0, 1, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0. Okay, so not many bits set here overall. And if we come over the PSM T4, so this is 0, 1, 0, 1, 0, 0, and this starts at bit 20, so where's bit 20? This count starts at 0. So let's go 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So it's these, we're going to need a different color here. If I can stop throwing my palette around, these 5 bits, right, are the PSM. So what did I say it was? 0, 0, 1, 0, 1, 0, 0, 0, 1, 0, 1, 1, 2, 3, 4, 5, 6. Sorry, it's these 6 bits. 0, 1, 0, 1, 0, 0. This is PSM T4. This is the correct value, right? 0, 1, 0, 1, 0, 0. Beautiful. So that leaves the rest of this word, right? 6B40. 6B40. Now, 6B40, okay, we should have some log up here about where our CLUT texture gets allocated. Setting CLUT to, uploading texture to, no, doesn't get logged here. Doesn't get logged here. Okay, we need to log the address that our texture goes to so that we can compare it to this. Well, first off, actually, where does this start? So 32. So it starts 5 bits into this. So 1, 2, 3, 4, 5. So let's grab this bit out, right? Let's grab these bits over here. So 6B4 0, 0. We ignore the first 5 bits of this, so let's go 1, 2, 3, 4, 1, 0, 0, 0, 0, 0, 1, 0. B is 1, 1, 0, 1, and then 6 is 0, 1, 1, 0. Okay. So 32, 33, 34, 35, 36, 37, 38, 39, 40, 41, 42, 43, 44, 45, 46, 47, 48, 49, 50. So this last bit is actually not part of this either. Let's go 0, 1, 1, 0. Okay, and let's do the same thing before so we can see how the grouping plays out, right? Because this makes it easier to spot when I've done a bad binary conversion. The zeros are just zeros. So this corresponds to the definition of this bit field, right? Bit 37 to bit 50. We have a total of 14 bits. 8 plus 3 plus 3, 8 plus 6, that gives us 14. That checks out. So here's the field. What does this correspond to? First off, so this is like saying 1, 1, 0, 1. Is it? No, we've got to build from the bottom. 0, 0, 0, 0, 0, 1, 0, 1, 1, 0, 1, 0, 1, 1, right? So you got to group by 4 building up from the bottom. 1, 1, 0, 1, 0, 1, 1, 0, 1, 0, 0, 0, 0. Yep, cool. So this is equivalent to 0, A, this is 5, and then this is 3. 3, 5, A, O. So now we can multiply this out. So 0x3, 5, A, O times 64 in hex. D6800. So this is what we expect the address of our CLUT texture to be in VRAM. I don't know if this is too high. Let's think about this. 878,592 divided by 1024 divided by 1024. So this comes in at under a megabyte of VRAM, right? Less than 1 meg, which actually might be too low given that we have 2 frame buffers allocated. Let's go into draw 2D. Let's go into VRAM even, not BRAM, VRAM. And let's go print allocating. I mean, first off, this is just wrong, but we'll live with that. Print allocating texture in VRAM. Allocate TED texture in VRAM. Let's go text.f name, because every texture has a file name. So now if I run this, hopefully it won't crash, and it doesn't. And we can see 878,848, 878,592. So that is the wrong VRAM address. Good. That's good to know though, right? So 878,848, we expect hex 878,848 divided by 64 to divided by 64 to be 35A4. 35A. So what this is saying is there is 1 bit is wrong in this number. Okay, we expect this bit to be set and it isn't. How could that happen? How could that happen? Could our multiplication be bad? Possibly. We could go into GIF and look at where we set text to and say CLUT text base pointer 2, we're going to set it to CBP. Okay? So now I can actually check in here, setting CLUT base pointer to 13728. We can check this in hex again, 5380. These are different numbers, right? These are very, 1 bit different is all it takes. All it takes to blow this all up. So that explains it. That really explains it. We have a chat message. First time chatter, Nimi, welcome. Welcome to the stream. Makes you want to learn C and try making your own. It's painful, but I love it. If you have a love for weird technology and weird hardware and stuff, I cannot recommend something like this enough. It's painful, it's stressful, it's exhausting, but oh boy is it rewarding. And, you know, we're having a really constant stream of viewers today. So again, thank you to everyone stopping by. My follow account has just, you know, continues to creep up. I've crossed 500 followers now. It's feeling really, really good. I really should fill out the paperwork and become an affiliate. I've only had that for over 2 years. When did I hit affiliate? I hit affiliate a long time ago. I've never done the paperwork. But now people are really watching. It feels like it's a lot more important to do. So yeah, you know, this has been awesome. I'm really enjoying these streams. So where's my bit going? Where's my bit going? It's not just in this calculation, right? We're passing in the wrong argument. And just as I say that, WooZex drops in another follow. Thank you so much. Welcome to whatever this is. Okay, so when we set CLUT, yeah, so let's log whatever the raw value we get is here. So let's say text.base ptr, right? Mad Supervillain needs to figure out which dumb old console he wants to program for. What have you got to choose from? I reckon Nintendo 64 dev would be really rewarding and really fun. Maybe once I master the PlayStation 2, I'll go try my hand at the 64. Or the Game Boy Advance, I think, would be really cool. Okay. Also, we do this twice, which probably isn't good. Okay. Learning the file, do blah 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 blah, logging. VRM setting here. Pick away pal. Wait. Texture and VRAM, yeah. So what happens if we divide this number by 64, right? I feel like these numbers all line up. Oh, hold on. Let me do the good old-fashioned integer division. 3580. Wait. This is what we have, right? This is okay. So if we calculate this two different ways, we get two different answers, basically. Where did this come from? Where did this come from? This value, where did I get this number from? Did I make this? Base pointer to this 13. So this checks out. This all checks out. That's not what I wanted to see. I wanted there to be something obviously wrong here. 858 878 592 13728. That's what we set this to. 13728. Base pointer 13728. Where did I get this number from? No, whatever. Okay, the important thing is it looks like this is being set correctly now. So if we go back to 16, register 16, the first time we set this, we just set PSM 32, which is good because that's a 32-bit texture. WooZex from the VRAM texture address. Yes, but now I'm logging it, it looks like they're all the same, right? It looks like, because this is the VRAM texture address. Like, we've got this unambiguously now. Oh wait, no, hold on. That's the palette. This is the... Oh, sorry. Yeah. I was looking at the VRAM address of the actual texture, which isn't right. I meant to be looking at this. I've got a laser focus in on this, right? This is the CLUT texture address. This is what we're setting here. So yeah, no, you're right. You're absolutely right. Thank you. That is, you're paying more attention than I am, apparently. I think I'm almost done for the day because this is starting to wear me down, right? This stuff does break you eventually. So we're setting this correctly. Could it be one of these other fields? Let me just have a quick look at these other fields before I give up for the day. CSA and COD, right? CLUT buffer load control. Oh, I guess the other thing is alpha, right? Could we be doing something weird with alpha? Because when we load a TGA, no, but that should be fine. That should be fine. As long as we have our other stuff set up correctly, right? Because we've got to do that. We've got to set the alpha in when we set up the color that we're drawing. Let's get rid of this other drawer as well, just to like absolutely simplify everything and make sure. Okay, so we set up the CLUT. We check these values are good. These values are very, very good. 6B40. This is what we want to see. I think this has beaten me. I think for today, the CLUT wins. But we've done everything, right? We've done all the bits. We've done all the bits. Offset, CSA. So yeah, like CLUT entry offset and CLUT buffer load control. Load is performed to... I don't know about buffer load. This is... Okay, hold on. 3.4.7. 3.4. What section are we in? Let me just like jump to this section real quick. 3.4. CLUT buffer control. Temporary buffer. Local memory. For texture mapping is used to convert a texture after copying from the CLUT buffer in local memory to the temporary buffer. After copying from the CLUT buffer in local memory to the... What's the temporary buffer? Where has this come from? What? Where is this? Oh, hold on. Texture buffer bay. Ah, I've missed a step. I've missed a step. CSM is... Yep, CSM. So this one... Huh. Okay. Okay. Exist. Only one set of CLUT data. CLUT data and the source specified. So this happens... So this gets loaded into a temporary register when text or text 2 is set. So that's fine. So we don't have to do anything. The CLUT data and the source is specified with these fields. Maybe occasionally... Yep. When CLUT storage mode is CSM1, that's good. The buffer starting address. Yep. Otherwise, we give it a thing. Buffer entry address, CSA multiplied by 16. Okay, so CSA is 0, so that's fine. So it's just address, or just offset 0 in the temporary buffer. The condition of loading to the temporary buffer. Ah. I should have read this more carefully. We want to set this flag to 1. Or maybe these. What's CBP 0? Control loading. Loaded from... Only in CSM1. Okay, so let's set this top flag to 1. That really does actually check out. That really does check out. I think this will still be wrong, but it's going to be something at least. Where are we? Text 2, CLD. Oh yeah, sorry. If I'd have used my eyes, I probably would have noticed this. Okay. Okay, here we go. So, load is formed as an buffer. Okay, CLD. So the top 3 bits of this number. So in other words, 1 multiplied by 2 to the 61. And you may think, does Lua like this? It really doesn't, but we'll be okay. Math.floor 1 times 2 to the 61. This should be fine, right? And we draw something again, but it's just garbage. Let's double check that we're actually setting this correctly. 16. Looks like we're maybe not. Are we? 16, 6B. No, we're not. No, we're not. Wait. We've also lost... Okay, hold on. We've lost a few things. Oh, yeah, hold on. That because... we're meant to be doing this. Yeah, cool. I was adding it onto the PSM, not to the actual value part. But now I think we've just nuked base address, so we've made it worse. Okay, so let's say local C, what's it called? The CD something. Again, I've lost my lost a bloody window. Where do I keep putting these windows? Where did they go? Okay, it doesn't matter. We're gonna give it our own name. We're gonna call it load mode equals. This is gonna be 1 times 2 to the power of 61, and it's gonna be the math.floor of this. And then we're gonna say math.floor of v plus load mode. I think this will work. If we look where we're setting 16, no, this is still 0. I think this number might just be too big. Okay, instead of this, can we just go v equals v plus v equals v plus 0x. What are we setting? We're setting it to setting it to 10. Oh man, this is when I do actually need. So it's the top 3 bits, right? The top 3 bits. So, and we're setting it to 010, which is equivalent to 4. So 4 0 0 0 0 0 0, right? 1 2 3 4 5 6 7 8. Mad Supervillain, by the way, may do some Mega Drive stuff. 68,000 assembly hell. That would be really impressive. There's that guy on YouTube, Gamer Hut, I think his name is. Yeah, he does some really cool stuff, and he talks a little bit about that. That looks like it works. That looks like it works. That looks like a color from our palette. So let's go back to draw2d.lua. Not draw2d, so let's go back to CLUT. Let's go back to where we create our texture, and let's say if I greater than 32, if I greater than equal to 32, then v equals 4. Okay, doesn't quite work. We still end up with just a grey blob, but it looks like, okay, it actually doesn't look like that grey is even in our palette. But we've made progress, okay? We've made progress. Kuachi stopping by. What is this nerd stuff? Kuachi, this is the future of PlayStation 2 homebrew game development, okay? We're going to build a PlayStation 2 game live on this stream. It's going to be blood, sweat, and tears, but it's going to happen. It's going to happen. Can I just like set some random other values? I can. Okay, so what I could do is regenerate a new texture every now and then that like changes color, that like enumerates different colors. What if I go to like, okay, what's a gutsy color? So if we have like 0 1 2 3 4 3, I mean 3 is a pretty gutsy color, 2 is a pretty gutsy color, right? Should be quite distinct. So we're not getting these in the right format. Now, there is another thing to consider with this, okay? There is one more thing to consider. And this is that when we set CPSM, this has to match our frame buffer. So our frame buffer may be in 24-bit color, and we're writing for 32-bit color, and that may be causing issues. So there are a few little things to check up on, and I will dig in and do this. But for now, it looks like this is like 90% of the way to working, right? We've got everything there. We've got our buffers. We're uploading just a texture we've pulled out of our arse. Everything is looking good to draw textures with this palette, right? I think it'd be cute to try and do like a little Pico 8 inspired scene, especially given that we're scripting in Lua, right? Like use the Pico 8 palette, but we're a little bit away from that yet. There's a few things still to do. So I'm going to call it there because my brain is melting, and I'm actually going to remember to host someone this time. All right, so let's have a look at who's streaming in science and technology right now.